Hello and welcome to this class. Today we are going to study the method of washers. Sometimes slicing a solid revolution results in discs with holes in the middle. We call them washers. See the diagram and accompanying volume formula shown in the figure. V is A times H, and A is a ring, so we can use pi r2 squared minus pi r1 squared. Alright, now let's see one example. Look at this region. Suppose the function for this curve is f, and the other curve is g. If I revolve it with respect to the axis, then it generates a hollow solid of revolution. When we slice it, the pieces are discs, so it's a hollow solid of revolution. When we slice it, the pieces are discs with holes in the middle. And we choose a typical piece at point x, and the thickness of this one is dx. So the area of this is pi f squared minus g squared. And the approximation of the volume of disk is pi f squared minus g squared times dx. Then we can get the total volume with the definite integral. Now let's see the example. Find the volume of the solid generated by revolving the region bounded by the parabola y is x squared and y squared is equal to 8x about the x-axis. So the function is kind of like this. Y is equal to x squared and y squared is equal to 8x. So the region is about this region. The key words are still, slice, approximate, and integrate. Let's see this figure. We slice it, then we find the area of the washer and times the width dx. Then we find the small value, we approximate, take the limit, then we have this definite integral. And this definite integral, we can easily to solve that because the integrand is a polynomial. So we find the total volume. Now let's see example 2. The semicircular region bounded by the curve x is square root of 4 minus y squared and the y-axis. And this region is revolved about the line that x is equal to 1. So it's revolved like this. And could you set up the integral that represents this volume? Okay, please take 1 minute to think about it. And is there anyone who wants to tell me what are the outer radius and the inner radius? Jack, would you like to share? All right, please.
Okay, here the outer radius of the washer is 1 plus square root of 4 minus y squared, and the inner radius is 1.
Thank you, Jack. Actually, the integral can be simplified. The part above the x-axis has the same volume as the part below it, which manifests itself in the even integrand. Thus, we may integrate from 0 to 2 and double the result. So we can find the volume. Notice that we can interpret one factor of the first integral, the definite integral of square root of 4 minus y squared, as the area of a quarter circle. So it's pi. And the total value of this definite integral is 2 pi times 2 pi plus 16 over 3. And we can simplify the answer like this. All right, that's all for this section. See you next time.